Alrighty, hey Honors Chemistry. I wanted to do a dimensional analysis problem with multiple steps and help you kind of understand the math a bit behind this. And you could use this video and rewind it and make sure that you understand how to do dimensional analysis. So one of the questions on your worksheet, it's actually one of the last questions, is how many milligrams is 59 kilograms? So I don't know off the top of my head what conversion goes directly from milligrams to kilograms, but I do know some conversions involving milligrams and kilograms. So conversions, I know. I know that there's 10 to the third milligrams in 1 gram. And I also know that there's 10 to the third grams in 1 kilogram. And I'm using that sheet that has conversion factors, or I'm looking up on my common conversion factors handout, and I'm going to use this somewhere. So now I'm going to start with a unit that I know, 59 kilograms. This is my fact, I'm going to call it. If you remember, the template for dimensional analysis is we do fact, which is the number fact that's given to us, and we multiply it times what I want divided by what I have. And when I say what I want, it's what unit do I want? And when I say what I have, it's what units are given to me. So in this problem, I was given 59 grams. So I'm going to start by writing 59.0 kilograms I was actually given. And remember, for significant figures, if I'm looking at this number, right now it has 3 significant figures. 1, 2, 3. Even though there's a 0 after a non-zero, there's a decimal point. So all 3 of these numbers are significant. Now, I want to begin converting my kilograms to somewhere, eventually milligrams, but in order for me to do that, I can't directly go from kilograms to milligrams. I'm going to have to go through something. So remember, my template is my fact times what I want over what I have. Well, I have kilograms, and I'm going to have to put kilograms in the bottom, 1 kilogram. The only conversion that I have in front of me that relates kilogram to anything is this 10 to the third gram. So I'm going to multiply 10 to the third grams here. This is my conversion factor, and what this tells me is that there are 10 to the third grams, same thing as 1,000, for every 1 kilogram. That's the physical meaning of this conversion factor. So I'm going to do 59.0 kilograms times 10 to the third gram divided by 1 kilogram. Now, with units, I have a kilogram here, and I have a kilogram here. They're going to cancel out. However, what do I want in the end? I want milligrams. In order for me to do that, I'm going to need another conversion factor. This is why I'm doing a second step, because if I'm canceling out right now, I'm left with just grams here, but I want milligrams. So I know I have grams at this point. I need to put grams at the bottom here. Eventually, I want milligrams. So I have grams, and I want milligrams. And I do have a conversion factor between milligrams and grams. That's this 10 to the third. So there are 10 to the third milligrams in 1 gram. And if I go and do this math on a calculator, remember, if I multiply a number times a fraction, I multiply the numerator and divide by the denominator. So I'm going to do 59.0 times 10 to the third divided by 1. And it's nice that divided by 1, I just get the same thing. So 59.0 times 10 to the third divided by 1. And then times 10 to the third again divided by 1. And just looking at my units, my kilograms will cancel out, my grams will cancel out, and I'll be left with milligrams. Now, if I plug this into the calculator, if I go and do this, I'll do 59.0 times 10 raised to the third, and then times 10 raised to the third again. I will get this crazy large number. I don't know if you could see it, but it's like 59 and then just a bunch of zeros. So I'm going to write that number down. So 59, and then I have 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6 zeros. So if I were to write this number, this looks like it's 59 million milligrams. Now, it's annoying and kind of not conventional to have all these zeros in a number. So remember scientific notation. So psi notation. I want singles place, and this is from a previous video. I want singles place, and I want the decimal point after that singles place. So if I'm looking at this number, any whole number that's not a decimal, you assume the decimal is on the end. So I have to bring this decimal point back to my first non-zero number. That's my 5. Watch my previous video on how to write in scientific notation if you're confused by this. I'm going to rewrite this number up here with all these zeros, which is annoying. 1, 2, 3, 4, 5, 6. And I'm imagining that my decimal point is back here. I'm going to bring it all the way to after the 5. For scientific notation, I want my singles place and then decimal point. So 1, 2, 3, 4, 5, 6, 7. I moved it to the left 7 times. This is a large number, and if I move my decimal point to the left, this is going to be a positive exponent in my scientific notation. So 5.9, 1, 2, 3, 4, 5, 6 times 10 to the 7th milligram. Okay? I'm hoping you could see that up there. So 5.9 0 times 10 to the 7th milligram. And that's a lot of zeros still. But wait, how many significant figures should I have in my answer? In the very beginning, I had 3 sig figs. I should have 3 significant figures in my answer. Well, here's one. The 5 and the 9 are definitely significant, and I just need one more significant figure. Well, I'll put that 0 back in. 590 times 10 to the 7th. These are my 3 sig figs. The way I should really write this number is 5.90 times 10 to the 7th milligram. This would be in scientific notation. Down here, without the explanation point, without the decimal point, this would still be 2 sig figs. That 5 and the 9 would only be 2 sig figs. But that's a problem because I want 3 sig figs. So it looks like a question like this, I need to express my answer in scientific notation. Oops, you can't see that. In order for me to get that 3 significant figures. Okay? And then one last thing I'll show you is multiplying powers times each other. So some of you were confused or how I could combine this 10 to the 3rd times 10 to the 3rd. Just to remind you, instead of plugging this into a calculator, you could also do 10 to the 3rd times 10 to the 3rd. And if I multiply 2 exponents by each other, that means I'm adding them. They have the same base of 10. So if you remember like x cubed times x cubed, if you know how to do that, you should know how to do this. X cubed times x cubed, that's going to be x to the 6th. So 10 cubed times 10 cubed, that's going to be 10 raised to the 6th. And that's where I'm getting these 6 zeros from. It's going to be 59.0 times 10 to the 6th, or 5.90 times 10 to the 7th milligram. Okay? In an earlier example in class, if I ever had raised a power to a power, if I had like 10 cubed and I cubed it, if I raise a power to a power, I'm multiplying the exponents. So 10 cubed would be equal to 10 to the 9th, because I'm doing 10, 3 times 3. 10 to the 3 times 3, so 10 to the 9th. This last minute or so was just to help some students understand how they could combine some exponents. But what's more important to me is that you could set up the dimensional analysis like we have before, and you could try to write in scientific notation, because sometimes you'll be prompted to do such. Hopefully this video was helpful. If you still have more questions or concerns, message me in the Remind.